A long time ago in a world far, far away, there was a big problem. No, bigger than a blue chicken. Even, a mathematician named George Cantor was creating a theory about infinite sets of numbers. Hey, that sounds important, right? Well, it is. That theory is one of the most important parts of higher math. But Cantor ran into a problem. His rules for infinite sets couldn't possibly work. How did he know? Because he tried to use his rules to define a set of all sets that are infinite. And that broke his rules. Whoops. Cantor wasn't too worried though. He figured someone had probably thought of this before. After all, mathematicians have been running into problems since the days of ancient Greece. But when he looked into it, he realized no one had ever solved this problem. That meant he could be famous for solving it. So he put his considerable effort into finding a solution. Meanwhile, a lesser-known mathematician named Bertrand Russell was visiting Cambridge University as a fellow. He was working on a paper about the foundations of geometry. But as he worked, he kept thinking about this infinite set problem. He couldn't stop thinking about it. In fact, he thought about it so much that he almost didn't finish his paper. But something good did come from it. While wrestling with Cantor's problem, Russell created his own paradox, which he included as an appendix in his paper. It was an example of a formally undecitable proposition, meaning a statement that can't be proven or disproven within the current state of mathematical knowledge. Russell sent his paper off to the editor, but before it was published, he got a letter. The editor said he appreciated the paper, but he didn't want to publish the paradox. Why? Because he couldn't decide whether it was right or wrong. Russell disagreed, thinking it should be published because it was mathematically interesting regardless of whether it was formally undecitable. He wanted to stir up discussion, but the editor stood firm, so Russell did something. He submitted the paradox to another journal. It was accepted and soon both papers were published, with Russell's paradox stealing the spotlight. Hey, that's kind of like the plot of Hamlet, except with more math. Anyway, Russell's paradox is this. Let's say there's a group of natural numbers, 1, 2, 3, etc. Now let's define a set of all sets that contain exactly one element. Then Russell asked, does that set containing all those sets contain itself? Remember, the set of all sets that contain exactly one element. Does it contain itself? Well, if it contains itself, it shouldn't because it's a set that contains exactly one element. And if it doesn't contain itself, then it should because again, it's the set of all sets that contain exactly one element. Russell's paradox shows that any attempt to answer the question leads to a contradiction. But that doesn't mean Russell was wrong. Instead, it means our current state of mathematical knowledge is incomplete. We need new rules. And George Cantor was the guy to find them. In 1963, Paul Cohen actually proved that Russell's paradox is formally undecitable. In other words, it will never be provable or disprovable with current mathematical rules. But back to the barber. What does his little paradox have to do with all this? Well, Russell used the barber as a simple example of a self-referential rule and how it can't work. Remember, the barber shaves every man in town who doesn't shave himself. That sounds simple enough, but it gets weird when you ask who shaves the barber. If the barber follows his own rule, he shouldn't shave himself because he's a man who shaves himself. But if he doesn't follow his own rule and he doesn't shave himself, then he should because he's a man who doesn't shave himself. Either way, the barber breaking his own rules. It's kind of like Russell's paradox, except with hair. So next time you get a haircut, remember, it's not just about looking sharp, it's about infinity. Well, maybe it is just about looking sharp, but isn't looking sharp kind of like infinite improbability? Never mind. If you want to learn more about Russell's paradox or other fascinating problems in math, check out the series in the description, and thanks for watching.